2020 National Electrical Code requires all 120-volt, 15 and 20 amp outlets in bedrooms to be protected by arc fault circuit interrupters, commonly known as AFCIs. This requirement extends to outlets used for lighting, general power, and appliances within the bedroom. However, smoke detectors are specifically exempted from this AFCI protection requirement. This exemption is rooted in the fact that smoke detectors are legally mandated to be powered by a dedicated circuit, ensuring they cannot be turned off inadvertently by a switch. The primary rationale for exempting smoke detectors from AFCI protection is to guarantee their continued operation even if an arc fault occurs within the bedroom's electrical circuitry. Arc faults can generate substantial heat, posing a significant fire hazard by igniting combustible materials. By isolating smoke detectors on a dedicated circuit, they are less susceptible to being affected by an arc fault and will maintain their functionality, providing crucial early warning in case of a fire. Having smoke detectors on a separate circuit offers several key benefits. Firstly, increased reliability. The dedicated circuit ensures that smoke detectors will continue to receive power, even if other circuits in the room are compromised by an arc fault. Secondly, reduced risk of nuisance tripping. AFCIs, while highly effective at detecting arc faults, can sometimes trip due to harmless conditions such as the operation of vacuum cleaners or power tools. By placing smoke detectors on a separate circuit, the likelihood of nuisance tripping that could disable the detectors is significantly reduced. Thirdly, ease of maintenance. Troubleshooting any issues with smoke detectors becomes more straightforward when they are on a dedicated circuit, simplifying the process of identifying and resolving problems. In conclusion, while it might seem intuitively logical to include smoke detectors within the AFCI protection of a bedroom, the National Electrical Code exemption is strategically designed to ensure their reliable operation in the critical event of an arc fault. Maintaining smoke detectors on a separate circuit provides increased reliability and minimizes the risk of nuisance tripping, ensuring that they are consistently prepared to protect occupants from fire hazards. It is important to understand the specific requirements outlined in the National Electrical Code regarding AFCI protection. The code stipulates that all 120-volt, single-phase, 15 and 20 ampere branch circuits supplying outlets or devices installed in dwelling unit bedrooms must be protected by an arc fault circuit interrupter. This requirement is intended to mitigate the risk of electrical fires by detecting and interrupting dangerous arc faults that can occur in wiring or appliances. However, as previously mentioned, smoke detectors are specifically excluded from this AFCI protection mandate. The reasoning behind this exclusion is based on the critical life safety function that smoke detectors serve. Smoke detectors are designed to provide early warning of a fire, allowing occupants to evacuate safely. To ensure their continuous operation, smoke detectors are typically connected to a dedicated circuit that is not easily turned off. This dedicated circuit is often backed up by a battery, providing an additional layer of protection in case of a power outage. The National Electrical Code recognizes the importance of maintaining the integrity of smoke detector circuits and, therefore, exempts them from AFCI protection. This exemption prevents nuisance tripping of the AFCI from disrupting the power supply to the smoke detectors, ensuring that they remain operational and capable of detecting smoke and alerting occupants to a fire. In addition to the AFCI requirements, the National Electrical Code also includes specific requirements for the installation and wiring of smoke detectors. These requirements are designed to ensure that smoke detectors are properly installed and function correctly. For example, the code specifies the locations where smoke detectors must be installed, such as in each sleeping room, outside each sleeping area, and on each level of a dwelling unit. The code also specifies the type of wiring that must be used for smoke detector circuits, as well as the methods for connecting the detectors to the power supply. Furthermore, the National Electrical Code addresses the interconnection of smoke detectors in dwelling units. Interconnected smoke detectors are designed to communicate with each other, so that if one detector detects smoke, all of the detectors in the dwelling unit will sound an alarm. This interconnection provides an added level of safety, as it ensures that occupants will be alerted to a fire even if they are in a different part of the dwelling unit. The National Electrical Code includes specific requirements for the interconnection of smoke detectors, such as the type of wiring that must be used and the methods for connecting the detectors together. When installing or maintaining electrical systems in dwelling units, it is essential to consult the latest edition of the National Electrical Code and to comply with all applicable requirements. This will help to ensure the safety of the occupants and to prevent electrical fires. The decision to exempt smoke detectors from AFCI protection is a deliberate one, aimed at prioritizing the reliability and functionality of these critical life safety devices. By understanding the rationale behind this exemption and the specific requirements for smoke detector circuits, electricians and homeowners can ensure that smoke detectors are properly installed and maintained, providing the best possible protection against fire hazards. In summary, while arc fault circuit interrupters are essential for protecting against electrical fires in bedrooms and other areas of dwelling units, smoke detectors are specifically exempted from this requirement to ensure their continuous operation and reliability. The National Electrical Code provides detailed guidance on the installation and wiring of smoke detectors, as well as the interconnection of detectors in dwelling units. By following these guidelines, it is possible to create a safe and reliable electrical system that protects occupants from both electrical fires and other hazards. The dedicated circuits for smoke detectors typically adhere to specific wiring standards as well. For example, the wire gauge used for these circuits often needs to be a minimum size, such as 14 American wire gauge or 12 American wire gauge, to ensure adequate current carrying capacity and minimize voltage drop. The National Electrical Code provides tables, such as Table 310.15b16, that specify the allowable ampacities of insulated conductors based on their size, insulation type, and installation conditions. When selecting the appropriate wire size for a smoke detector circuit, it is important to consider the total load on the circuit, including the current draw of the smoke detectors themselves and any other devices that may be connected to the same circuit. It is also important to account for any directing factors that may apply, such as those for ambient temperature or conduit fill. In addition to the wire size, the type of wiring used for smoke detector circuits is also subject to specific requirements. For example, the National Electrical Code typically requires that smoke detector circuits be wired with non-metallic sheathed cable, such as type NMB, or with conduit and individual conductors. The cable or conduit must be properly secured and supported to prevent damage and to ensure that the wiring remains in place over time. The connections to the smoke detectors themselves must also be made in a safe and reliable manner. Typically, smoke detectors are equipped with terminals or connectors that are designed to accept the wiring directly. These terminals or connectors must be properly tightened to ensure a secure electrical connection. In some cases, it may be necessary to use wire connectors, such as wire nuts or crimp connectors, to join the wiring to the smoke detector terminals. These connectors must be listed for the intended use and must be installed according to the manufacturer's instructions. Another important consideration for smoke detector circuits is the overcurrent protection. The National Electrical Code requires that all branch circuits be protected by an overcurrent device, such as a circuit breaker or fuse. The size of the overcurrent device must be appropriate for the ampacity of the circuit wiring and the load that it serves. For smoke detector circuits, the overcurrent device is typically sized at 15 amps or 20 amps, depending on the wire size and the total load in the circuit. The overcurrent device must be located in a readily accessible location, such as a panel board or circuit breaker box. It must also be clearly labeled to indicate its function, such as smoke detectors. In addition to the overcurrent protection, smoke detector circuits may also be required to have ground fault circuit interrupter protection in certain locations. Ground fault circuit interrupters are designed to detect and interrupt ground faults, which can occur when current leaks from a circuit to ground. Ground fault circuit interrupters are typically required in bathrooms, kitchens, and other areas where there is a high risk of electric shock. While ground fault circuit interrupters are not typically required for smoke detector circuits, they may be required if the circuit also serves other outlets or devices in a location where ground fault protection is required. The National Electrical Code provides detailed guidance on the requirements for ground fault circuit interrupter protection, including the locations where it is required and the types of devices that must be protected. In addition to the wiring and overcurrent protection requirements, smoke detector circuits are also subject to specific testing and maintenance requirements. The National Fire Protection Association, also known as NFPA, standards such as NFPA 72, the National Fire Alarm and Signaling Code, provide detailed guidance on the testing and maintenance of smoke detectors. These standards recommend that smoke detectors be tested monthly to ensure that they are functioning properly. Testing can be done by pressing the test button on the smoke detector and verifying that the alarm sounds. The standards also recommend that smoke detectors be cleaned regularly to remove dust and debris that can interfere with their operation. The cleaning can be done by vacuuming the smoke detector or by wiping it with a damp cloth. In addition to the monthly testing and regular cleaning, smoke detectors should also be replaced every 10 years, or sooner if they are not functioning properly. The replacement date is typically printed on the smoke detector itself. When replacing a smoke detector, it is important to choose a replacement that is listed and labeled for the intended use. It is also important to follow the manufacturer's instructions for installation and testing. By following these testing and maintenance requirements, it is possible to ensure that smoke detectors remain in good working order and provide reliable protection against fire hazards. The National Electrical Code and other applicable standards provide detailed guidance on the design, installation, and maintenance of electrical systems in dwelling units. By following these guidelines, it is possible to create a safe and reliable electrical system that protects occupants from electrical fires and other hazards.